All right, a shout out to Justin for sending me this link. I've passed it on to all of you. This is a link that talks about how to manipulate strings in Swift. I'm guessing that a big chunk of that is in the book as well, maybe more, but this does hit some of the highlights. If I were wanting to know how do I manipulate strings, these are some very common uh, techniques. We talked about mutable and immutable. In Swift, a mutable, immutable string is just a constant. You can't change it. So you can't concatenate something to that. So that's a little different from what we're used to, those of us who are Objective-C programmers. You can define individual characters. In most languages, strings are comprised of it's an array of characters is what a string is defined as. Individual characters stuck together, but we manipulate strings so much that they've become embedded in most languages. They are embedded in Swift. And you just deal with strings. It's rare that we deal with individual characters anymore. If you wish, you can define a character, but you do have to type it because notice that there are quotation marks around characters. So how is this different than a string? It's only got one character in it, and it's assigned to a character variable. That's the difference. If we assign this to a variable on its own, it would be considered a string. I don't use characters much anymore, unless I'm manipulating strings character by character, then occasionally, but it's pretty rare. Initializing to the empty string, concatenating strings and characters. Okay. Those, by the way, notice work just fine. If you have well, those aren't strings and those aren't characters. Here's a character. I can concatenate strings and characters. You can join a character to a string, but it doesn't work the other way around. So the character has to be here. So that's interesting. But just by concatenating, you can concatenate. But we're not going to mess too much with characters. So let's keep moving here. Loop through each one of the characters in a string occasionally comes in handy. For each character, this is a variable in a string. One of the things I noticed about the for in loop, instead of the for each loop, it's a for in loop here. For each is my generic term in it for it. Kind of like a case statement. It's my generic term. It's for what is in Swift a switch statement. But this is a variable. That's not the character type. That's a variable. Notice you don't have to define its type. For each character in that string, if this was an array of integers, you don't have to define the type of this loop variable. It just figures it out. So for each character in the string, print it or process it however you want. This is defined of type character. It's rare. Counting characters in a string. Most languages, that's called length. Okay. Or string length or something like that. Here it's count elements. Okay. That would not be, that's one I would be documenting in my journal because I'll be looking for something called length and it won't be there. That's interesting. What if the count changes from 99 to 100? Does the count change because now the string is longer than it was before because the number of characters in the string is a different number of characters, changing the size of the string, which is determined by, whoa. What if there's 99 characters around here? What happens when this is 100? I think it's a fixed value, so it's not too bad, but the number itself, the number of characters in this number would change. Doesn't that change the size of the string? So now I'm using the size of the string inside of a string, which could affect the size of the string.
No, that's just pointing a line that says my string. It's just using it's just
I understand, but this variable could have 2 digits or 1 digit or 3 digits, which makes the size of the string. Oh, no, it doesn't. No, it doesn't. You're right. But what if I was assigning this to a variable? That would be ugly because then the contents of this.
I wouldn't let you do it, I guess.
String interpolation we already talked about. That's these parentheses and the backslash.
I just tried to say that's a string, even called my string, and it just takes the count to 4.
Yeah, I can see what it would do, but that was a little.
Cursorily into it. It counts its own character, or counts its own character.
This is important. Right, here's checking for string equality. Bob and Bob are two different strings, but they are in different places in memory, right? Because they're two different variables. Here we're comparing them, and according to this example, if they're the same, the strings are the same, and it actually checks them character by character. In earlier versions of curly bracket languages like C++, if you compare these two strings, even though they have the same characters in them, the answer is false because it's checking, when you say if my string equals my other string, it's actually checking the address of those two variables to see if they're the same. And they're not. It's not intuitive. Most of today's curly bracket languages, when you ask this, it compares them character by character because that's what you want, probably as a programmer. Now Swift does it. I don't think Objective-C did it before. Now Swift does do it so you can compare two characters. And so this leads me to believe that I could do this. And it does. Okay. There's also a function. Excuse me. There's also a function built in that you can do, so let's try that real quick. It's not a function, or it's not a method, otherwise you put parentheses on it. That's bizarre. And Brittany wants to talk about functions. Maybe when I call functions that don't have parameters, I don't have to put parentheses there anymore?
Or is that a
Function, or is that a property of the string?
It's a property.
Maybe it's a property. Okay. So either one of those, they both make sense to me. I'm used to double equals the empty string. In other languages, though, that was dangerous because the empty string literal has a location in memory temporarily, which is never going to be the same as a variable. And when you tried that in some of the older languages, it wouldn't work. Now it does. So either one, acceptable. What else do we have here? If a string contains another string, most languages would simply say contains. This one says contains string. Seems a little redundant, but okay. Whoa, what? I hope not. I have to say bridge to Objective-C contains string, although Apple writes that Swift string type is bridged seamlessly, assuming you have a contains string method should be available to use, but unfortunately it doesn't seem to be the case currently. Okay. So let's test that out. Not there. Yuck. What does it say? Bridge to Objectives. Do I have what?
The framework of Objective-C.
Do I have the framework? I think it's built in.
I can't find it in the completion list.
No, it's not on the completion list, but maybe you have to import it.
You need parentheses after Objective-C. I think.
Seems to work.
This is a bizarre example anyways. He doesn't have a variable called string. But contains is very handy, so if it's not available, that's going to be annoying. That one I have found has suffix and prefix, right, but no contains. That's annoying. It's got to be something. So we'll have to watch for that one. When you find a solution to that one, let me know, because maybe I didn't see anything though that came up with contains. Nothing.
You can create an NS string to do it.
God, I hope not. Gonna go through this whole process and not have a contains. There's
You have
a
Objective C inside Swift, if I'm understanding.
well, that's annoying. And this bridge, there must be a way to get to that. If my string range of string, this, I'm guessing range of string allows me to find out what the range of this string is. And a range is a 1 to 5, something like that. But if it's not there, then we'd have issues. So that's
Oh,
to look at range of
you
string.
don't have to do that. You don't have to do
So it's that, like, would you use that when,
Yeah, I think it's contains.
so your database is a, like a,
It's STR.
I can't remember, like, there was, you could have a string which is 240 characters or something, then a long string or whatever, which is, I don't remember what it was in the
Yeah.
database. So would you use that to say, if it's, the range is, to make sure that it's less than 240?
No, the range, what it's really looking for is where it defines a range. And I haven't tried this one yet, so I'm out on a limb here because the next question is how do I determine what's in that range? If my string, range of string, what it's really asking here is in my string, what is the range of the word this? And in this case, it would be 0.3 or .3, something like that. A range is a class
Okay.
that includes a beginning and an end. And how to get at it here, he doesn't explain. But what this leads me to believe is if this is not in there, this will be false and it will print it's not there. So this might be our temporary workaround for contains, is to use range, and if it comes back false, it's not there. If it finds a range, then it basically comes up true, which according to some of the notes I've seen in the book, doesn't work anymore either. In many languages, 0 is false. 0 is equivalent to false. And any number, including negatives, positives, ranges, are true. This range of string has to return a range. Why would that be a Boolean? It's bizarre if this works. Because the range of string would not return true or false. It would return a range, which is a class. But maybe the class has built into it a technique that if somebody wants a Boolean, it just gives it to them. But what I read earlier on, we were reading about Booleans, is that 1 and 0 are not equal to true and false in Swift. They're not the same. Right, so that one's a little bizarre. A range is a class with a beginning and an end. I could understand it returning false if it's not there, but I don't understand this working as true if it is there. Looks like we got a substring. Okay. What if you want to pull the this gives me a substring, jumps over the first 2 digits, and grabs the rest. That's from index to index 2. Wow. Substring is one of my favorites. I end up using it a lot. Pull a string out of the middle of a string. But what I don't see here, this gives me everything starting at position 2 to the end. This gives me everything from the beginning to position 2, but I don't see anything here that allows me to pull them out of the middle unless I use those two in combination somehow. Would be a real pain
Big pain, yeah.
compared to normal languages. Right? So that's substring. So let's see what we got here for substring. Substring from index
With range.
with range. Ooh, but that has to be a range. So let's see if I can figure that out. If substring with range, I have to put a range here. But this goes back to Justin's question, what's a range? Can I do this 1.3? You happy with that? No. Triple dots. Happy with that? No. So I first have to define a range as a type, then put the 1 to 3 in there, then stick that into something. No, I don't know. You better not leave me with that. And I don't want to have to say, give me this as the beginning point, and then give me this as the end point. That would be a pain as well. So hopefully they'll provide us with a substring somewhere in between there. Because this range, there's a way to do this. I forget what it is. I think you define a variable of type range. There's the type. The range generator.
Make our own extension method.
Yeah, right. We're going to make our own for something that should be built into the language.
Well,
So that's something else to keep our eyes open for. Here's trim. Gets rid of white space.
I just tried the substring. I'm not sure if I'm doing it.
No. Splitting strings into an array. Have we done that?
I have to erase that.
Have we done usually in most languages it's called split.
I think it was extra credit.
It was extra credit in one of your assignments possibly. Where here's a string, split it on every space, and it creates an array of strings without the spaces. Or if you're doing a comma delimited file, separate them by commas or comma spaces or whatever you're searching for. And you can split, and then there's usually a join that goes in the other direction.
It says that it contains the spaces still though, in that one.
It will still contain them.
Well, look at the comment.
Okay, so here we're looking for just a comma. It still contains the spaces,
Okay.
but not because it doesn't. But if you were searching for comma space, then it would, I believe, remove everything. But in this case, he's only searching for a comma.
In New York,
But even here, it's removed the spaces. Oh no, there it is. It's in front. It's in front.
You could,
But I'll bet if we did this example, I wonder if I can cut and paste. Cool. And if I don't, oh, but it's separated by string. Aha, see? Strategy. The space is gone. Okay, I still have all my features here, except I didn't get the last one, did I? Or is there only, no, there's 4. So the nice thing is we can do that, separate them, and now I have an array indexed of cities. And that's a comma delimited file, often has spaces, sometimes it doesn't. String processing, I mentioned it in Programming Logic Intermediate, is one of the most common things you do. It just comes up all the time. My attendance program, when I import, it's all string manipulation. Does the string contain a parenthesis? If it is, then you found the right line. Stop, process it. Okay, where is the parenthesis? Give me the 5 characters in front of the parenthesis because that's the section number. And it's on and on and on, that kind of processing. I seem to do it all the time. So it's important, I think, to get a good handle on what you can do with strings. And I, again, like this document because it talks about the kinds of things we do a lot. Splitting using more than one character. So here we created an array that says either dashes or spaces. That's interesting. But that's or characters, not multiple strings.
that's so long.
Yeah, and you know, and that's an interesting comment because he said that's so long. That's Objective-C. The stuff we wrote in Objective-C was really, really hard to read. Because they had all these really nice long names, and because we can, so why not have names that are really descriptive because they're so long? We had IntelliSense that helped, but it was a bit of a challenge. Converting a string to NS data. NS data is a type that's used with databases and a few other things, and boy, look at that. String data using encoding NTFS UTF-8 string encoding. Oh boy. NS is new. What was the S? System, I think. Next step. I read somewhere about where these names came from. Objective-C is really old. It's been around for a long time, but then the next computer came out that Apple created way back, I want to say it's 80s, 90s. And they modified the language, and the NS stands for next step. So it's an enhanced class that's built into the language, and there's so many of these NS classes that it just makes your head spin. All right, so what was I going to do with this? I was going to demonstrate. Let's go back down to here. And I should be able to toggle. Yep, that was Command/again to toggle the comments. So that comes in handy.
What was it called?
Command/.
Not the command, thing you did to do the font.
Command/. One of the things I saw, I think it was in the book, was this. Case let x where fruit has suffix berry. Now that's an ugly looking case. But what this says is it actually does a calculation first, puts the results in x. Right. Does the fruit have a suffix? That's an ending of berry. If it does, store it in x and match the case, all at the same time. And initially, I still pick a cherry, but if I change this to strawberry, you picked a strawberry. If I change it to blueberry. So this does multiple things here. So does it end with? This is kind of like saying, does the case end with? And putting, I don't know if you can put a true up here. That would be interesting to test. But I'll do that in a second. So this, I see that as pretty powerful.
Where's the where?
Where did the where come from?
Yeah.
It's a keyword built into the language. But let x where fruit has suffix. I saw it in an example. I tried it. It worked. This is one of those examples I'll keep in my pocket. Does it include these words? If it does, go into this case. By the way, the default, which is also bizarre in many languages, you can put the default anywhere and it'll work. In this language, default has to be at the end.
So that leaves me to leave it test it top down in order.
Yes,
Each case.
yes. And again, what if it matches more than one? If I have blueberry in here, how many cases does it match? One, and it matches the first one, and so it'll tell me that I picked an apple. So if this covers multiple cases, the next thing I want to know is this. Switch true. Seems to be legal. Case. Fruit double equals apple. Doesn't make much sense to just echo the apple that you picked, but let's do this.
semicolon
No.
for colon?
Okay. So apple fruit is blueberry, so this should be, let's put it down here. I skipped over that quotation mark by pressing tab. If there's a bunch of gray text there that Swift has inserted automatically for you, you can skip over by either typing it yourself manually or pressing tab. It'll skip over the gray text. In this case, it's the end quote, which isn't a whole lot. At least it's in there. And I picked a blue fruit. And so up here, if I now change it to apple, and I picked a red fruit. And so this works as well. And so now I can do things like if A is greater than 20. I can say switch to case A greater than 20. And if that's true, it'll process it. If A is less than 30, process it, and so on. So this gives you quite a bit of flexibility in the switch statement. Okay, Brittany wants to talk about functions. So let's go do a little research on functions. And again, thanks for sharing that link. That will come in handy as another nice reference. Counting characters, who cares? Comparing strings, suffix, prefix, has suffix, and it skips right over. Collections, didn't talk about substring or a bunch of other stuff. So collections are similar to an array. We'll talk about those sometime in the future. We're going to make Brittany happy today. Okay, let's... Closures are getting close. Functions. Functions are self-contained chunks of code. Function syntax is flexible and express anything from a simple C function to a complex objective C function. Boy, are they ugly. Every function in Swift has a type consisting of the function's parameter types and return type. This is an interesting statement. Each function has a type that is a combination of its parameter types, so what you send in and what it sends out. Many other languages call that the function's signature. And that way you can have functions with multiple names. In other languages, you have functions with multiple names, where sometimes you send in a string, sometimes you send in an integer, sometimes you send in two integers, and they all have the functions all have the same name, but they have different parameters, so they have a different signature, and the language figures out which one is which. Not so in Objective-C, not so in Swift. In Swift, the type, the name of the function is actually all that stuff stuck together. And so most languages would call that a signature. Here they're calling it a type.
According to what I've read, recommended or not, you can also return multiple variables.
Yeah, that's the tuples. That's new to me, and when I need it, I'll think about it.
Or even a function that returns the function.
Yeah, there's all kinds of power and flexibility here so that you can have a function that returns a function. I'll process, and if this is true, then you call that function. If this is true, you call that function. If this is true, you call that function. So it returns the function, and then you call it on the other. That's a bit advanced for us. Okay? If you look at the first programming assignment, it's not terribly hard. Okay? Some of the super advanced function stuff can get real nasty. All right, so calling and defining and calling functions. Let's take a look at what a function looks like. Start with keyword func. Interesting. Why not function? Is it so much longer that you can't call it function?
NS function.
There's no NS function. That's not a class. This is a function built in. Here's my function name. This is a parameter. Notice that parameters must be typed. That makes sense to me. Okay. I'm going to send you something. It wouldn't be a generic type. Right. So it must be typed. And then this is the return type. And this is new syntax. There are languages that use something similar to that, but it is not the same syntax that Objective-C used. So this is new to me. I've seen this angle dash thing before. I think it's PHP that does that for some things. Okay, I've seen it before, but this is the first I've seen it here. So here's a function. So let's steal it. Command C to copy if you've forgotten that from the other day. And Command V to paste. Got a little carried away here.
Oh,
Cool. Okay, so there's my function. Notice nothing happens out here. Right? We have to call it first. This is the function's name. And then in parentheses, we send what we want to send in. That's different than Objective-C. Of course, I don't know if it goes in parentheses. I haven't gotten to the next page yet. This is, if I call this by saying hello evoker, right, I'll be surprised. Because that's modern, but it's not Objective-C. I think the call would be something like this, print line, say hello, and send it a string. Wow. What's going on here? Well, this is what came out of that line. Okay, so this is just the playground showing me line by line what's processing. I'm returning the greeting, hello evoker, and then down here I actually printed it. This is significantly better than what we had to deal with in Objective-C.
Could you just get rid of or put line 6 where line 7 is?
Yes, can you combine those is probably what he's saying to me here. So let's try it. Can we just say return the calculation, right? Because I don't even need the variable. Yep. So now that we've figured it out, let's do a little reading. That's what they did. Okay, say hello.
I
Say
think
hello.
we also call the function twice instead of saying the hello within the function, it says 2 times.
What?
If you do the print line, say hello again after the rover.
Yeah, it'll do it because that's embedded in there. That's called,
The function will say that you ran it twice.
And the output
just try to
would
call
say
it
that
again.
it did it 2 times instead of just once.
I mean, if you say hello, run the say hello function after that.
after where?
In other words,
After the
duplicate
print line.
line 10 is line 11.
Have 2 print lines.
With the say hello function called inside.
Like that?
Yep, and then the function on the right says it run it 2 times.
Oh, okay. Yeah, it's been called 2 times. So it's telling me how many, at this point, how many times has it been called. It was the same thing with the loop. How many times did we process? Remember that we could hit the white circle here and it will show us the output, please, of the entire program. Maybe. There we go. Okay. So let's read a little bit further here. Functions and return values. Extremely flexible. You can define anything from a simple utility function with a single unnamed parameter. Really? To a complex function with expressive parameter names and different parameter options. Multiple inputs. Put commas in between. That all looks good.
I think it's weird that the type comes after and not before.
Some languages will put the type over here, you're right, right, in front.
Well, wouldn't it, like in C#, isn't it int start, int space start?
Yeah. Yeah, when you build functions there, if they return a value, you would see that, and there's no word
And
function.
inside the parameters.
Yeah, I mean inside the parameters. So
Here?
The-
Oh, yeah, you'd flip it around, but remember where we are, right? We're in Swift, and if you
Right.
give it a type, the type comes colon after we do in var age colon int if we're going to define it. So that's the way we define variables, so at least it's consistent. So there's nothing terribly new there. Functions without parameters returns a string. Functions without return values, no dash angle. Makes sense, because it doesn't return, you don't include the dash. Strictly speaking, does return a value even though value functions without a defined value return of type void. That's normal. We don't have to explicitly state it here, where in many other languages, if your function returns nothing, you have to say so. So here we can leave it out, so that's good.
Fine, and also if you have two functions with the same name and return type, but different parameters, it will still work.
Yes, because again, the function's type is a combination of its parameters and its return value, all of them. So in this function's type is string int, technically. This function's type is string void, technically. Okay, so even if these two have the same name, that's perfectly legal. You can have two functions with the same name as long as their parameters and return types are different. Yes, sir.
I don't know if I'm skipping ahead too far here, but what about the like public and private that you usually have to put before functions in C#?
In C#, everything is a class, right? And in C#, even our main program was part of the big class, and so there you didn't have to define public and private. If you don't define it, it's considered public. Is it here? I'm not that far yet. Functions with multiple return values. This is a tuple. Okay. This function returns an integer and another integer. You have to put them in parentheses, and then on the other end, you have to take them apart. You have to store them in a variable that ends up being a tuple, and then you pull them apart using dot notation. It sounds just like a class, right? That's what a tuple is. It's a temporary class, or a temporary, not predefined in a folder somewhere. Doesn't have functions built into it. It's just a bunch of variables lumped together without an array, without it. So it's like a class. A tuple, my English definition in my head, a tuple is like a class without all the overhead. You just put a bunch of things in square brackets or parentheses, and then you pull them apart. Because back here, we put them in parentheses. That's bizarre. But I also don't write a lot of functions with multiple return values. This is an interesting function. Give me min-max. Sounds like the function has two functions, two purposes. And that's often what I will tell my students is if you're writing a function that has the word and in it, that's two functions, not one. But if I always want the min and the max, then why not write a function that gives me both? I suppose. But why not write two functions that gives you one and the other, call it twice, and then when you only need one, you have to have the function. I guess here, if I only need one, I could still call it and ignore the minimum. Better one way or the other? Tough call. So, Brittany, how am I doing?
I'm getting it.
You're getting it. All right. Oh, here, this is always important. Functions with optional return types. That's interesting. I'm more interested in optional parameters than optional return types. Yuck. Function parameter names. However, these parameters only used within the body of the function cannot be used by a calling function. These kinds of parameter names, local parameter, we know that. Right? If you give this a name, it's not available outside. External parameter names. External parameter names. Anybody want to translate that?
I think there's stuff there.
As what?
I haven't gotten that far.
Okay, well, I'm just wondering, external parameter means external, it's available outside the function? That's a call by reference is what I would call it. In other languages, it's a call by reference. You send the address in. But this parameter name is now available. Sometimes it's useful to have a parameter that you call, and if you change it inside, that's just a bad idea in general. So I'm going to skip over that for right now. Takes too many pages. Shorthand external parameter. Yuck. Default parameter values. Here we go. You can define a default value for any parameter as part of a function's definition. If the default value is defined, you omit the parameter when you're calling it. So how do we make them default? Oh, whoa, really? With joiner?
No, that's the function that you used earlier.
Here's the version of the join function from earlier, which provides a default value for its joiner.
Or maybe it's equals, etc.
And the default value is a single space.
Right. So when you call this function called join, you send it two strings and you want to join them together. If you don't send it anything, and it doesn't have an example of that here yet, if you just say join Volker, comma Gall, it'll give you Volker space Gall because you didn't define the joiner. If you define the joiner, but notice that, what? Join, string, string, I have to define that as a string?
Maybe so it knows which signature to use.
Oh, I'm going to have to look at this a little bit more. This is where I'm going along with Brittany. This is getting confusing. Okay? Plus, we're out of time, which is good. So we'll have to take a look at this. But notice the call here includes the words in front. I thought this was the type, but it's not. Because it's lowercase string. This is the to string. We're naming the parameter, but why do they have two names? I think this name is for internal purposes, and that name is for external purposes.
My guess is you can, they're all optional, and so and then when you call it, you need to tell it which one it is, so you don't need them in the same order necessarily. It's just a thought, it might not be.
That could be too. In one of the, I'm trying to remember which language it was. It might be Ruby on Rails. You can flip your parameters around. Doesn't matter what order you put them in. So this is S1, string S1, two string S2, but why they have dual names, one for internal, one's external, is all I see here. I have a suspicion there's an easier way to do this, but we'll check it out next time. So keep plugging. What do we still need after functions? We still haven't talked about arrays. So for next time, what I would like you to do is get through this functions the best you can, get through the arrays and collections as best you can. And then review your notes one more time. See if there's anything in there that was kind of interesting that we didn't talk about. So that we haven't talked loops too much yet, so we might have to talk about those. But maybe I'll have a little more structured approach to it next time, because my to-do list has only got 5 items on it now, and one of them is continue working on Swift instead of one of 20. So we'll keep plugging along.